everyone. How are you? Okay, semua? All right. Okay, today we're going to do a few things. Number one, we're going to look at application. First, the partial derivative. And then we are going to discuss about the second partial derivative. Second partial derivative means the higher order derivative. So these two things that we're going to do today. Now, you want to finish up first on the quotient rule. What we did last time, we did the product rule, but we haven't done the quotient rule. So let's do the quotient rule. Quotient rule, when you do the partial derivative, it's just like what we were doing for the previous topic. The rules apply, okay? The rules apply. The formula for the partial derivative, that is the u prime minus v prime. Oh, you look. Is it okay now? Pagi tadi okay? Internet saya okay? Saya punya ni pun okay tak? Okay dah? Dah boleh? Saya cuba cakap kuat sikit. Okay, now I will try to talk louder. So the quotient rule. Okay, remember the formula for the quotient rule. If you have f of x is equal to u divided by v. So you use that formula and we apply it to the partial derivative. Now I give you an example. Suppose we have f of xy or z equal to 4x squared minus 7y. Yeah, let's say we have something like this, divided by 3x to the power of negative 3 plus 5y to the power of 4. Everything squared. Okay, so suppose we have something like this, and you want to find fx, fy, and we are using the quotient rule. And here, let's say I have squared. Here, let's say we got 5.2, 5.3, 5.6. We don't have the number 6. So 5.6. Okay, so the formula, if you recall, if in terms of one independent variable, what? Y equal to uv, then what is y prime? I'm sorry, not y, uv, y divided by v, then u prime is equal to u prime v minus v prime u divided by v squared. So that is the rule. Okay? So now we're going to apply it to the function with two independent variables. So first we find fx. Okay, so that's the formula here. And now the u prime is what? U prime is of course df dx lah. Okay, so what you do here, if you remember the rule, you let u be equal to the top. You got 4x squared minus 7y, 5 to the power of 6. And u prime here, okay, u prime is du dx. Here it should be partial. So what do you get? You get 8x. Okay, and then you let v be the denominator, 3x to the power of negative 3 plus 5y to the power of 4, everything squared. Now our v prime is du dx because I want to find fx. So what is it? is equal to, you bring down the power, multiplied by everything in the bracket, reduce the power by 1. Okay, now you multiply by the derivative of the things in the bracket. So I got negative 9x to the power of negative 4. So that are the terms that you need. Okay, all right. So now you put in the formula, divide by v squared. Okay, I want you to do it. Okay, put everything and make sure divide by v squared. So I already have everything here. So x is equal to, so you got all those terms, you know, subtraction, multiply, everything divided by 3x to the power of 3 plus 5y to the power of 4 to the power of 2. 2 squared, okay, 2 squared. So you got everything here 2, and then square again. So you multiply 2 times 2, so that becomes, okay, so that is the denominator. So I give you 2 minutes, okay, put in the top terms. You don't have to simplify, just put in the respective terms. Okay, all right, good. So now we want to do F1. So the formula is still the same, but here, okay, the u prime is what? The u prime is du dy, because we are going to do the partial derivative of the function with respect to y. So you let u be the terms, so u prime now is du dy. All right, so don't differentiate with x, because you are talking about y. So take derivative with respect to y. What do we get? You will get negative 7 multiplied by 5.6. Y reduce the power by 1, so 4.6. So again, we have what? You have u. All right, u is 4x squared minus 7y to the power of 5.6. U prime here du dy. So we got that one. So you can multiply 7 multiplied by 5.6 and see what you get. And then similarly, you do the v prime, and now v prime is du dy. So make sure we don't confuse finding the same thing, du dx. So there we go to what? We go to 2 multiplied by 3x to the power of negative 3 plus 5y to the power of 4, reduce the power by 1, so that's power 1. Now, derivative of the terms in the bracket with respect to y. So I got 20y cubed. But the numerator will be the same. Okay, you have v squared. The only things that are different will be u prime and v prime, which you have to do accordingly. Okay, all right. So finish it up. Put in everything, you should get the Fy. Okay, I'll give you 1 minute. Okay, we're going to look at applications. Now, application, We will go back to 14.1. 14.1, they give you a few examples of application which you use this kind of function. And then we will do the partial derivative. Mostly the application is on economic. So if you look at 14.1, first example is application is on the utility function. So firstly is utility. As you know, utility is what? Utility is a measure of satisfaction. U, and it's a function of more than one good. U is the function of, for us, you know, two goods, X and Y. And X good and Y can be any good. And then that is another example. One example. The other example is example number 5. You have production. Okay, how you organize the input to produce output. So 2 examples in. Now let me go into a little bit more detail about the application of utility. So utility here is, you have U as a function of X and Y. So this is utility. X and Y normally 2 goods. Okay, they are goods that give you satisfaction. Example, the X can be what? Can be not kok lah. Kita pergi punya. X can be tarik. Okay, tarik in say cups, and Y can be roti canai. Everybody knows roti canai. In English, I don't know in English what we call roti canai. I think it's the roti canai or prata. You know, in India, Pakistan, they call it prata. Roti canai in pieces. Okay, so your satisfaction would come from the consumption of X and Y, where X is teh tarik, Y roti canai. So that gives us utility. Right? Okay. And then you want to draw this utility function on X, Y. We will let U be constant. Okay, if you let U be constant, say U equal to 100, okay, 100 units of satisfaction, then what do I have? I have f of xy equal to 100. Okay, and this f of xy is some form of x and y. So if you look at example number 4, you have u x squared y squared. So you got x squared y squared equal to 100. And now you can write down. Alina. Diam. And then you have y, you summarize, you simplify that. So you got 100 over x squared, everything to the power of half, that will be equal to 10 over x. So that is what we call indifference curve. Okay, if you have taken economics, principles of economics, you might come across infinite difference curve. Difference curve give you combination of x and y that create or generate a constant or the same level of utility. So you will see the indifference curve will look something like this. So that is utility. We call it utility, and we draw it with on a graph x, y. So indifference curve will look like this from the function that we have, the type of function that we have. Okay, So that is utility. Now, if you look at example number 4, let's go through example number 4. You can find the level of utility if x equal to, say, 10, y equal to 2. So suppose we have teh tarik roti canai. Okay, you can find the level of utility. Let's say x equal to 2 cups of teh tarik, and then roti canai 5 pieces of roti canai. Itu memang kuat makan. So what level of utility will give you? So what you do, you substitute into the function. So substitute into u equal to x squared, y squared. So that will get you utility. All right, so that is example number 4. We go to example number 5. Example number 5, in this note, they don't give you example 5. They only give you up to utility. So example 5 is the production. No, production, you have, I have inputs. You combine the inputs, then you produce output. So that is production. And it is denoted by Q, and here a function of X and Y. We can use X and Y, but specifically for inputs, we generally just denote the inputs by capital K and L, where X is capital. All right, capital in units. And then Y, normally it's L, is what label also in unit. So suppose, consider an example. You are producing one good. Okay, you are producing one good. That means I normally give burger, tapi burger I give already example last semester. So today, this semester I want something new example. Apa lagi? Example, one example. Example, roti canai. Roti canai is a good example. So example, roti canai. Okay, so roti canai, in order to produce roti canai, what do I need? What do we need? We need capital. Okay, this capital, you don't think capital in terms of money, okay? Capital, of course, capital can be money. You think capital as a good, okay? Capital, and then you need labor. And of course, you need all the other inputs lah. But now we just say labor and capital. The capital for making roti canai is the kitchen, the stove. Right? So let's say the frying is not frying. Okay, what do you call it? It's the fry you put in oil, but that one you don't put in much oil. You just put a little bit oil. So I don't know what you call it. Anybody knows that thing? What do you call it? So that roti canai, the stove. We call it the stove lah. Okay, that stove. And then labor, the number of. So you combine the number of workers and the number of stove, then we produce roti canai. Okay. Now suppose I got one stove, 1 unit, and I got 1 unit of worker. Okay. Now what he does will be, he has to do 2 things. One is to flat the dough. Okay, he has to do this thing dough, and also he has to do the cooking. Okay, so he has to do the cooking. So he's doing 2 jobs at one time. I mean, not at one time lah. He has to do 2 jobs. the preparation of the dough to make it flat, and then to cook. Okay, and because you have only one stove. Now, if you change the number of workers, let's say I have 2 workers. Okay, I have 2 workers, and then 1 stove. Then what you can do here, one will prepare the dough, 1 person will do the cooking. So you see here, you can get more roti canai. Okay, so that's how you combine the inputs, okay, to produce roti canai. The more inputs that you have, the more we can produce. All right, okay, good. So let's say you consider the example as given in the book. The function is given. So you got Q is equal to 4, capital 0.4 and L 0.6. So you have that function. A is capital, L is label. So you just read that example, it's similar to example number 4. Okay, next. We move on to applying the partial derivative. Okay, if you do the partial derivative to this function, what do we get? The book, they just use production. So we just follow the book, right? So let's say you are looking at production. So now you move on to 14.3, example number 3. Same thing, production. Okay, so what you want to do here, you want to take the partial derivative of the production function. So there are 2 partial derivatives. Number 1 is Q, K. I just use K. Or in other words, there will be F, K. And that is what? That is dQ, dK. Okay, so partial derivative of output with respect to capital. And then secondly, I can also do QL, that is FL, this dQ, dF. Okay, all right. Now, in economics, what do you call this? If you take the derivative of the production with respect to capital or labor, what do you call that? So think of it as delta Q, delta K. And here, think of it as delta Q, delta L. So what is the derivative of Q with respect to K and L? What do you call it? It's marginal, okay? It's always marginal. The term is marginal because you take derivative. Now, if you take the derivative of Q with respect to K, what do you call it? Marginal apa? Anybody remember? It's marginal? Marginal product of capital. Or MPK. And then the second one, that will be the marginal product of labor. Okay, MPL. So it's just a derivative of the function with respect to K, with respect to L. All right. Okay. Now you go to that example. You got the function as given in example 4. Oh, I'm sorry, not example 3. Example 4. So go example 4. Example 4. 14.3. So you think of it as delta Q, delta K, but for now, I don't need that. So I take it out because we just want to do the partial derivative. Now you look at the example number 4. What is the partial derivative of Q with respect to K? What do you get? You look at that function. That will be equal to what? That will be equal to 100. The X is capital. Okay, X is capital. So that X is capital. So what I want you to do, kita write balik lah. Okay, so 100 k to the power of 1 over 4, L to the power of 3 over 4. So I think, okay lah, tak apa. So 100, k is the x over there. So that will be equal to what? 1 over 4. K reduce the power by 1, so that is negative 3 over 4. Multiplied by L, 3 over 4. So by now, you don't have to make any change, because you know that you take derivative with respect to K, the label is fixed. So you don't have to rearrange lah, time. Then dq dl, right? dq dl, so you got 100, k to the power of 1 over 4. You bring the power of the L, so L negative 1 over 4. So you can change to decimal point if you like, but you can maintain it as it is. So you can simplify. That will be equal to 25. Okay, so here also 25. So I got 25 and 75. And then you can bring the negative power down. Okay, you can bring it down. Now, what you want to do next is that we can find the level of Q. Okay, we already did that for the utility. So you substitute into Q. Okay. Now, what you want to do here is I want to find the marginal productivity. So I want to find the marginal productivity. So I want to find MPK and MPL. Okay, so how do you do that? All right, I want you to do it. Okay. So let's say, suppose currently we have 10 workers, and then the number of stove is 5. All right. Now I want you to find MPK, MPL. Okay. All right. Give you 3 minutes. So the first person who get it, let me know so that we can go to the solution. Alina. Again. Okay, you got it? What did you get? Anybody get? So you can use, 1 over 4, that is 0.25. Power dia susah pula. Saya pun lupa nak put a nice power. 3 over 4, that is 0.75. So you can use decimal point. Okay, anybody get the value? So MPK, okay, MPK, which is that would be equal to 25, 10 to the power of 0.75 divided by 5 power 75. Okay, anybody got it? I don't have my calculator. I don't know. No, my granddaughter picked up that. I don't know where it is. Anybody get that? Tell me. MPL, you got QL, that will be equal to 75 K 5 to the power of 0.25 divided by 10 to the power of 0.25. Okay, anybody get it? Let me know.
The first one for K is 42.04.
42.04. Is that right? Somebody check.
Yes.
Okay, good. Okay, now MPL berapa?
$25.
25?
675.
75.
63. Oh, yeah. 63.
I couldn't hear
63.06.
75. I don't think.
No, 63.
63.
63.06.
Point, point zero.
06.
06. Okay. Or 63.06. Everybody, somebody check. Is that right? Another person get the same thing, we assume true. So these are the values. Okay, the marginal productivity. Now, marginal product of capital, marginal product of labor, like I said earlier, when you want to explain it, we think of it as just the basic slope. So MPK meaning what? Meaning QK, that is delta Q, delta K. In other words, it's just delta K, I'm sorry, delta Q, delta K, just for the linear function. Okay, so if you want to interpret that, that means what? If I increase capital, if I use one more unit of capital, then what happens to my output? Output will increase by how much? By the value of the marginal product of capital. Okay? So that is the basic. But of course, this is non-linear function. You have to add a little bit more. Okay, so let us start with the basic. So the basic one is that if we add, if the firm hire one more capital, so if the firm increase capital by 1 unit, okay, capital by 1 unit, then what happened to the roti canai? Capital ni stove lah, okay, use one more stove, then the quantity produced, okay, the quantity of output produced will be what? Will increase by how much? By 42.04 units. So in this example, the one I'm talking about general, the quantity of output. So in this example, the quantity of roti canai, okay, of roti canai will increase by how much? 42.04 pieces. So you can round out to 42 lah. All right. So that is the basic that comes from here. Everybody knows, okay, that comes from the linear function. But this is non-linear. And then on top of it, it's partial derivative. So what do you have to add? You have to add the point of the derivative. Where did you take the derivative? So we add, okay, add this add K equal to 5, L equal to 10. So in other words, given currently we are using 5 units of capital, 10 units of labor, 10 workers. Okay. So if I increase stove by 1 unit, then how much more roti canai I can produce? The amount of roti canai produced will increase by 42 pieces. Okay, now for partial derivative, one variable will be constant. Okay, here what change? Capital change. So what is the input that you keep constant? Labor. So I add here, keeping, okay, the other input constant or the other variable constant, keeping labor constant. Okay, constant at 10 units. Or you don't have to put the word 10 pun tak apa. Okay, just keeping labor constant because I already say at K equal to 5, L equal to 10. So given now capital is 5 units, you add one more. That means now you have 6 capital. So by doing that, I can produce 42 more roti canai. Okay, is that clear? Any question? Anything?
Yes, sir.
All right, good. So I want you to do the explanation for the MPL. So you follow what I write here. All right, you have to state first the point where you take the derivative. Secondly, you have to say which variable you keep constant. Of course, you know, Sn will be just right at the beginning. So I want you to try write down the MPL, the derivative with respect to labor. Okay, all right. So you still use the same point because we are taking a derivative at that point. So you say that at A equal what? K equal to 5, L equal to 10. Okay, so if we hire one more worker, they will hire one more worker. Or just say that if labor increase by one more unit, somewhere if we increase labor by 1 unit, then what? Then the number of roti canai, number of roti canai produced increase by how much? Increase by the amount MPL, 63.06, or you round out 63 units pieces. Tak habis gitu. Sikit lagi. Keeping what? Keeping capital constant. Okay, keeping capital constant. A equal to 5. This one you don't have to say it, it's okay, because you know the point. So if given that, currently you have 10 workers, 10 stove, if you add one more labor, okay, you hire one more worker, then what happened to the roti canai produced? The amount of roti canai that can be produced will increase by 63 pieces, keeping capital constant. So you don't add any more stove, you just add one more worker. So that is marginal productivity of labor. So if you look at the marginal product of labor is 63 units, 63 pieces of roti canai. marginal product of capital is 42 pieces of money. So if you add any of the input, which input give you more increment in terms of output, which output will increase, which input increase output more, labor or capital? Saya share screen tak tadi?
Share.
Yes, sir.
Nanti saya duk cakap, tapi kamu semua tak nampak benda ni. Alright, so which one is, in short, which one is more productive, labor or capital?
Labor.
Which input give you more increase in output?
Labor.
Labor lah. Okay, because MPL is 63, MPK is 42. All right, so therefore, you say that MPL is equal to 63, and that is bigger than MPK, which is equal to 42. 42. Is it 42 or 42? Okay, 42. So you increase one more worker, Potichana increased by 63. But if you increase capital by one more unit, Potichana increased by only 42, which is smaller. So since the MPL is bigger than the MPK, so better to increase more output. Okay, increase more output, more Potichana. What we do? We add labor, okay, rather than adding capital. Because you add one more worker, I can add 63 more Potichana. If I add labor, I can only add more 42. And of course, the point, okay, the point will be here, that K equal to 5, L equal to 10. Because at some other point, this may not be true. Okay, you have to look at the point where we are now, right? Because these are non-linear functions. Okay, all right. So what I would like you to do, there are a few things that I want you to read. Just read. Okay, just read the things. Same, you apply the first partial derivative. Number one, I want you to read example 1. Okay, example 1 that is on 14.3. And then I want to read the other example 5, 6, that is on the demand function. Okay, so demand of a good. Then you look at the concept, competitive and complement. So complement, competitive. You know, in economics, competitive goods. When there are goods, two goods, they are complements. Competitive means substitute. Okay, so, normally in economics, we use substitute. Competitive means substitute. So some goods can be complement, some goods can be substitute. So in order to do that, we can use the partial derivative to indicate, all right, whether the two goods are complements or otherwise. So that is example 5 and 6. So I want you to read and do that example. Okay. So this one kena buat. Okay, this one kena buat. Yang ini tak buat apa tak apalah. Alright, this one kena buat juga, tapi not as important. The more important will be example 5 and 6. Okay, so we are done with the application 14.1, 14.2, 14.3. So I give you some questions on the application. 14.3. I would like you to do question number 2, that is on the cost. That will be example tadi lah. Okay, number 2. And then the production, you can do number 15, 14. And then on the demand function, we can do number 24. Right, 24. Okay. So I think that'll be it. Okay. So that is the application 13, 14. If you want to do it, you have to do one more question. Okay, if you want to do more, you can do utility dalam cost production demand. So 13, 14, if you want to do, then you can do number 21. Okay, all right. Any question? Any comment? Anything? Okay, good. So we are done with that part, application of the partial derivative and the explanation. Now, what you want to do next is you want to look at the second partial. We call it higher order derivative. So higher order derivative, we have to look at 14.2. 14.2. Okay, 14.2. They have the second partial derivative. So we go back to 14.2. That is the second partial. Alright, so kita tengok ni. Kita tengok dulu. I want to show you this thing here. Tak tengok betapa, tapi saja ya. Alright. First, the partial derivative that we have been doing now. Okay, that is what you call first partial. Okay, first partial because there is first partial derivative. Okay. Now, when you do the partial derivatives of the function z equal to f of xy, you have what? You have fx, and then I have fy. So that is the notation that we use. We can use dz or dz dy. So we just call it fy, fx, zx, zy. Depending on which notation you like. Okay. So use fx, zx. Of course, you can use df dx, dz dx. So many, there are at least 4 of them. And similarly, if I take derivative of the z with respect to y, I got fy or zy, dz dy, df dy. Now, this partial derivative, or the first partial, they are also function of x and y. Okay, because there is, you will get a function of x and y. So therefore, you can differentiate further. You can differentiate fx. So that is what you call the second partial. It's just like second derivative. Okay, so that is the idea. So let me continue here. So you got fx. Now fx is a function of xy. We know that already. Similarly, the partial derivative of the function with respect to y is also function of x and y. So therefore, we can continue to differentiate. Okay, you can continue to differentiate fx, fy. With respect to what? With respect to x, y. So that is what you call the second partial. So you take the derivative of f of x. This is the first partial. Sometimes we just call it partial derivative of f. Okay, and then the partial derivative of fx is the second partial. Okay, so this is like you. Okay, the children. The function is your parent. This is you, first partial. Okay, second partial is the cucu, the grandchildren of your parents. That means your children. Okay, so you got second partial. We should put S because there are more than one. All right. So how many derivatives can we take? Okay, if you look at fx, I can differentiate fx with respect to x because fx is a function of x. So what is the fxx or zxx? We just use the simple notation. If you look at the book, okay, I will show you the book. Give you the more notation. Ada ke? Kita bagi ya. Sampai sini je. Okay, ni. Right? First order, second order. Tak ada bagi notation. Higher order. Maybe it's okay here. All right. So here, zxx. You take the derivative of the function with respect to x. So in other words, I take derivative of dz dx with respect to x. Or you can call it d2x, d2z dx. Or you don't have to write this, refer to the book. So that is zxx. Okay. Now, that function fx or zx is also depending on y. So you can take derivative of zx with respect to y. So what do I get? I get zxy or fxy, or d2z dy dx. So don't think about this. You know, that thing. Okay. Now zy or fy, I can take derivative with respect to y. Okay, so you get zyy, fyy, and then it's also a function of x. So I can take derivative of zy with respect to x. So I got zyx or fyx. So there are 4 second partial that we can do based on the first partial. Okay. Any question? Okay, that's coming from the book. So you got fxx, and then I can take the derivative of fx with respect to y. Okay, because it's also a function of y. So I got fxy, which is equal to xy. Okay. Now similarly, fy is the function of y. So I can take fyy, which is zyy. Now it's also a function of x. So I can take the derivative of y with respect to x, or zyx. Okay, all right. This thing here, we call it cross partial. Fxy, fyx. So these 2 things here, we call it cross partial because you have the partial derivative fx you differentiate with respect to y, or the partial derivative fy you differentiate with respect to y, to x. So you doing the derivative with respect to the other variable. So it cross partial. fxx, fyy, you are doing it with the same variable. So we just call it direct. Okay, direct partial. So these are just okay. All right. So let's consider an example. For example, I think first we start example dalam buku. So if you look at the book, all right, you look at the book. I have this example here. Okay, you have x cubed y minus 3xy plus 4. Okay, all right. So now what I want you to do, we already know the first partial. Okay, you have fx or zx, you have zy or fy. Okay, now they already did the second partial. So what I want you to do, you do it by yourself. Okay, don't look at this thing. You just look at fx. Okay? This one. Take the derivative with respect to x and take the derivative with respect to y. We must get okay, the answer. Okay, just I want you to just spend 2 minutes doing the x, y. Okay, got it? All right. So you got this. Now, what I would like you to do, you do the second partial of fy. Okay. So fy is zy. You find zyy or fyy, and also you find zyx or fyx. Okay, you got it? The answer is already in the book. Okay. You do that thing, and then you check the answer, whether we got it right or we don't. Okay, all right. So I'll give you a second example. I would like you to do the question that I assigned to you earlier. Okay, go to 14.2. I give you many questions last time. So if you have done this, it's good. You can do let's try question number 3 first. Do number 3, you already find fx or zx, okay, and will be between fy and zy. So what I want you to do, go back to the question. If you have done, that's good. You can start from here. If you have not done, that means you have to do everything. So I want you to do the second part. Afterwards, I will go. Okay. So question number 3, you do that question. Get the second part. Okay, do it now. I give you 3 minutes. Okay. The first person who get it, let me know so that I can continue and go through. Don't worry whether you got it right or you got it wrong. All right. I just want to know you do the second partial. The first person who have done it, just beritahu. Finish? If not yet, I give you 2 more minutes.
Done, sir. Done, sir. Done.
Okay, good, good. Okay, so you have question number 3. Okay, question number 3. So I haven't done the question. That means I have to start from the beginning. Okay, now is Azan. Okay lah. I will continue back after Azan. Okay, we take a short break and I'll come back after Azan. You do the second partials. I have fxx, take derivative of fx with respect to x. y constant. All right. So there will be 6x plus 8y. Is that right? 6x, 8y. X. Y is a constant, x is derivative. And then fxy, derivative of fx with respect to y. The x squared is a constant, 8x constant, so I got 8x. Fy, we do fyy. Y is the variable now, so that is 12 of 4x squared. And then fyx, the derivative of fy with respect to x. Okay, you check your answers. Anything, betul ke? Everything same? If you get wrong, okay, do the correction. Check where you get it wrong. So this is the solution. Okay, all right. I give you one more thing. Okay, I give you one more question. This one more difficult. So second, I would like you to do question number 6. Okay, do question number 6. Okay. Tak apalah, kita dah masuk. So masuk kita buat kemudian. Buat lagi. Let's do the one yang similar to the one that I have. Sekejap. Mana lagi satu soalan? Okay, you do question number 29. Oh, dah habis lah. So do question number 29. Okay, 14.2. Question 29. I give you now, we have 3 more minutes. I'll give you 3 more minutes to do that question, 29. So you have to do first partial. If you have done it, that's good. If you haven't done, that means you have to do first partial and then do the second partial. Okay, so do 29. Now, for the second partial derivative, so the second partial, what you can do, or what not what you can do, what I want you to do, you just extend the questions that I gave you last week. Extend the previous, okay, the previous homework question that I have given you. The ones I give you last week, we do the first partial. Okay. So for the same questions that you had done, you do the second partial. So that's what I mean by the extend. Okay, you do the second partial. So I give you already some questions last week. So do the second partial derivative. But if you haven't done, that means you have to do everything again. First partial, second partial. Okay, I give you 3 minutes. Okay, first person who finish, let me know so that we can go through that thing. Okay, so number 29, number 29, we go through, you check your answers. I use fx because I prefer fx than zx. Now, not right. Fx is equal to 2xy. By now, you don't have to rearrange the terms, all right? Constant and coefficient minus 4y. Okay, fy, what do we get? We got x squared minus 8xy. Now, the second partial, fxx, derivative of x with respect to x, what do I get? I get 2y. Okay, 2y because y is a constant. So the f4 was 0. Then fxy, derivative of x with fx respect to y, I got 2x minus y. So I multiply right away 2 and 4 becomes 8. Power reduced to 1 by 1. So you got 8y. Okay, and then fyy. Fyy, take derivative of y, fy respect to y, I got negative 8x. And then fyx, take derivative with respect to x, I got 2x minus 8y. Okay, everybody got it? If you got it wrong, check where you went wrong and make the correction. Okay, now if you look at these answers, the second partial, there is one pattern, okay? There is one consistent pattern that you see. What is it? We do two examples already. You look at the example, the second example, and that is that can be generalized. Okay? That is true for everything. Now, what pattern can you see there? For the second partial, all right. Don't worry about the first partial. Any pattern that you see? Anything? Okay, hurry up. Kita dah balik dah ni. Time's up. If you repeat the course, okay, if you repeat the course, maybe you know this already. What is the pattern? What something that you can see, be consistent, the same? What is it? Okay, what you can see here is this. You can see fxy, fyx. They are the same. Okay, you check the previous example, it's also true. So one pattern fxy should equal to fyx. So what we normally do is that when you determine fxy, you find fyx, they must be the same. If they are not, okay, suppose you don't get it, that means we make a mistake somewhere. So you have to go back and check. Okay, you have to go back and check because either fxy is wrong or fyx is wrong, or both are wrong. So that's a mistake. You have to check. Okay, they should be the same. If they are not, maybe something wrong that we did along the way. Okay, so fyx must equal to fy, and that's good because that is one way to check our solution. Okay, all right. But we don't take advantage of this now. You don't do fxy, you dapat fxy, and then you don't have to find fyx. you just make it f by x equal to the same thing. Don't do that, that is wrong. Okay, you have to work it out to make sure or to show that they are in fact the same. Okay, all right. So I think that's it for today. I will see you again on Wednesday. So the questions I give you, please do it, because on Wednesday we're going to use the second partial derivative to test for maximum minimum. So that is the second derivative test for partial derivative. So that is important, okay? Wednesday class is important because you're going to do the test. Okay, all right. So I will see you again. Have a nice time doing the homework. I will see you again Wednesday. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
Okay, thank you. I'll see you.
Thank you,
Thank
sir.
you, sir. Thank you, sir. Have a nice day, sir.
Okay, thank you.
Sir.